This will be a review of basic one-step equations, the ones that you did in 6th grade. The only thing that should be different, if there is anything different, is the way that I would like you to write them as you review them so that we can be better prepared for the complex equations that you're going to be doing in the 7th grade. So you're going to write a few definitions, and then you're going to write some example equations in your notes, and then you're going to have an assignment at the end to practice basic equations. There will also be some inequalities. That means they will have greater than or less than signs in them, but they will solve the same way that you solve your equations, and we'll review that. So in your table of contents, you will write equation review, and then on your notes page, you will write the same thing. When you're ready, or you can pause the video as you write this in your table of contents, and then when you're ready, press play again. Hopefully you recall that we've looked at these types of expressions. An expression is a series of numbers and or variables along with possibly math operations. Since there are only numbers in this expression, we called it a numerical expression. And terms in an expression are separated by addition and subtraction signs. What we want to use is PEMDAS here, order of operations, in order to simplify this expression. And simplify merely means to do all the math that you can. In a numerical expression, of course, we can do all the math because we know all the numbers. So what you end up with is the most simplified form, which means a number. When we get to variable expressions in a moment, you'll see that that's not always true. So in order to use PEMDAS on this, we would start with our parentheses, 2.4 minus 5.9. Changing that to addition, you get 2.4 plus negative 5.9. And so, on our next line, we would have 2.6 plus 6 minus negative 14 times 56 divided by 8 plus negative 3.5. Next, we're going to look at multiply and divide in order from left to right. And if you'll notice, in this expression, we have a multiply that comes before our divide. Multiply that comes before our divide. So we're going to do negative 14 times 56. There's one negative sign, which means that our answer will be negative, and 14 times 56 is 784. Okay, so now we're ready to do division. Negative 784 divided by 8. There is one negative sign. Our answer will be negative. 784 divided by 8 is 98. All the multiplication and division has been done. We're ready to add and subtract in order from left to right. I'm going to go ahead and change my subtraction to addition so that I can rearrange if I want to and have all of the positive numbers in one end and all the negative numbers at the other end. So I'll have 2.6 plus 6 plus a positive 98 plus negative 3.5. Now, adding all the positive numbers, I'm going to have 106.6. So I'll have 106.6 plus negative 3.5. And now I'm ready to add the last two numbers, which have different signs, which means I'm really going to subtract them. 106.6 minus 3.5 will be 103.1. The largest absolute value here is positive, so my answer will be a positive 103.1. When we look at the next expression, the algebraic expression, we will be using PEMDAS also, order of operations, to simplify algebraic expressions, but we'll find that our answer will not always be a number. We will have to simplify it. We'll have to do as many of the math operations as is possible, but sometimes we won't be able to do the operations because a variable represents a number we don't know, so we won't be able to do the operation. This is an algebraic expression. You'll notice that in this expression, we have numbers, variables, and math operations. We still have terms. Terms are separated by addition and subtraction signs. So I want you to write down algebraic expression. An algebraic expression includes at least one variable. In this case, you can see that we have x's and y's. Everywhere you see an x, they represent the same number, even though we don't know it. And everywhere you see a y, it also represents the same number, although it is not the same number as the x. Again, terms are separated by addition and subtraction signs. So you could count the terms, although we have a parentheses, which means we'd have to take care of that. So here we're pointing out the variables. Remember that anytime there is a variable next to a number, it means multiply. Terms are separated by addition and subtraction signs. So where there is a multiply, that does not mean there's two terms. 3 times x plus 2 times y, that would be two different terms. We can do some of this math. For instance, you could do 5 times 6 times x. You couldn't multiply by the x, but we could end up with 30 times x here. We can't do 5y minus 14 because I don't know what 5 times y is. So there's some math in this expression that we could take care of, and there's some that we cannot. We would still use PEMDAS, and as we simplify these, for instance, here's a parentheses, there's a multiply. We can simplify some we cannot. When we end up with our simplified version of this expression, it will not be a number. It might be an expression still. Something times x plus something times y minus some number perhaps. We'll be doing those, we'll review those again this year. Remember that x's and y's are different unknown numbers. Although everywhere you see an x, it represents the same number. So we're going to write down variable, and we're going to remember that a variable represents an unknown number. So it is just a number that we do not know yet. We're going to look at variables, particularly when we talk about equations. So we're going to define equation. An equation is two expressions that are equal to each other. So we're going to have to remember that the key here is that they have to be equal. So we're going to have an equal sign, but that we are talking about two separate expressions. And this is going to be something that's a little different perhaps than the way you did it in the 6th grade. So we're going to start with our equal sign, and then there will be an expression on either side of the equal sign. And we're going to remember that we're going to draw a dividing line down this equal sign, and whatever is on one side might somehow be related to the other one because they're equal, but they are independent expressions. And we're going to treat them as independent expressions. So we're going to draw this little dividing line, and we're going to remember that they are separate. So it might be something like 5 equals 5. That's the simplest type of expression. It's a number, and it's true. 5 is equal to 5. It might also be something like x is equal to 13, or m is equal to c, Or something as complex maybe as 2x plus 14 is equal to 9y minus 32. All it really means is that each of these expressions is equal to the expression on the other side of the equal sign. So we might have something very simple. We might have an unknown. It's just telling us that the variable is equal to something. Might be something we have to take on faith, two variables that are equal to each other. Or it might be something very complex that we're going to learn how to solve this year. 2x plus 14 equals 9y minus 32. It takes a very complex process to solve. But what we're really going to do this year is review how to solve basic one-step equations, something that you did last year. So we're going to start with just a basic addition equation, x plus 14 equals 6. And we're going to remember that there's a dividing line down this equal sign. So x plus 14 is one expression, 6 is another expression. I'm going to keep them separated. We're going to look for the expression that has the variable in it. There's x, it's on the left side. And we're going to think about what is being done to the x in that expression. There it is. And I want to solve it by getting to a point where I have x alone again. So whatever is done to it, I want to undo it. I want to do the opposite thing. So I'm looking at x, and I can see that 14 is being added to it. So I want to do the inverse operation, the opposite thing. The opposite of adding 14 would be to subtract 14. So if I undo it, if I take it back off, then I'm going to subtract 14 from that expression. Not from x, but from the expression. So I'm going to subtract 14 there. So if I took it off, then that would leave me with just x again. Because somebody added 14 on it, and if I take it back off, then I'm going to be back to just x. And that's what I'm going to think about. I'm not going to look at the other side. I'm not going to think about what's over there yet. I just want to know, how do I get x to be back by itself? But I'm going to have to go back to that definition of an equation. The definition is two expressions that are equal to each other. So if they were equal, and then I took 14 off of one side, I got to go back to that 6 now, and I'm going to have to take 14 off of it in order to keep them equal. Because the definition of an equation is two expressions that are equal to each other. So now I'm going to do my math. 6 minus 14 becomes 6 plus negative 14, and I get negative 8. So x is actually equal to negative 8. And I know this seems like, several steps around what you did in the 6th grade, but when we get into more complex equations, it's going to be important for us to remember that these expressions are separate from each other. I want to think about what do I need to do to the one with the variable in order to solve for the variable, and then do the same thing to the other one. And that's the key. We're going to keep them as separate expressions. We're going to look at a couple more. So let's look at m minus 12 equals negative 3. Again, we're going to keep our expressions completely separate. So I'm going to look for the one that has the variable in it first. I'm not even going to look at the other side. I'm going to identify what is being done to my variable right now. I can see 12 is being subtracted from it. What's the opposite of subtracting 12? Well, it's going to be to add 12 back to it. So if I add 12 back to it, then I'll be back to where I have just m, which is what I want to do in order to solve. So now I have m again in my variable expression. I go back to think about what is going to keep that equation equal. I've got to add 12 to the other side again. Now I have negative 3 plus 12, and m will equal 9. So we're going to look for the variable expression, identify what is being done to the variable, do the inverse operation of it, which means to do the opposite, make sure that we do that opposite thing on the other expression, and you have to show me that in your homework. I have to see that you understand that those expressions are separate expressions. And then you'll solve for the variable in that process. Okay, well, we're just going to look at a couple more kinds of equations because I want to do all the basics one-step equations. If we look at one that says negative 6 times y, a number right next to a variable, equals negative 20, I'm going to look for my variable again. The y is my variable. It is being multiplied by negative 6. The opposite of multiplying by negative 6 would be to divide by negative 6. So I'm going to take that expression and I'm going to divide it by negative 6. Negative 6 divided by negative 6. Make sure you get both of those to say negative. We'll end up with just back at y, because negative 6 divided by negative 6 is 1. 1 times y is the identity property, will give me just y. So on my expression with the variable in it, I have gotten back to having just y. That's the only side I want to look at to begin with. Now I'm ready to think about they have to stay equal. So I'm going to go back to my negative 20. I'm going to say, well, I got to do the exact same thing. So if I divided by negative 6 over there, I'm going to have to divide by negative 6 on the right side. Notice we're using a fraction bar to divide and not that divide sign. So it's negative 20 divided by negative 6. I have two negative signs, so my answer is going to be positive. And 20 divided by 6 is going to be 3. 2 remainders, so 3 and 2/6, which is going to be 3 1/3. And you can show the 3 2/6 and then simplify it to 3 1/3, or you can just write 3 1/3 because that is a very simple, simplified process. If we do it with a division type problem also, then we'll start with an equation that looks like something like c divided by 0.2 equals negative 4. In this case, my variable is the c. The thing that is being done to it is to divide by 0.2. If I want to do the opposite of divide by 0.2, that would be to multiply by 0.2. You can see that if we put that over 1, do some cross-canceling, you're going to end up with 1 times c. Again, that's your identity property. 1 times c is going to be c, which is where we want to be if we're solving. So c equals. Always take care of your variable side first. But I do have to go back and keep my equation equal. So if 0.2 was multiplied on the variable side, I'm going to multiply the negative 4 by 0.2 also. I have one negative sign, so my answer is going to be negative, and 4 times 0.2 is 0.8. So in all these cases, you're always going to look at the expression where the variable is first, decide what operation is being done to it, do the opposite of that operation so that you end up with the variable all by itself. once you've taken care of the variable side in every case, then you go back and you make sure that you do the same thing, the same operation with the same number on the other expression. We're going to look at some inequalities this year. Greater than, less than. And so we're going to talk about what that means. When you solve an equation, you get one answer. But if I talk about something that's like x is greater than 14, that means x could be lots of things. It could be 14.4. It could be 15. It could be 9,643,910. It could be, many numbers. If I say y is less than or equal to 63, that means it could be 62. It could be 63 because it says less than or equal to. It could be negative 18. It could also be many answers as opposed to just one answer if it says y is equal to something. But you solve inequalities, things with greater than or less than symbols, the same way you solve an equation. It's just that instead of thinking of keeping them equal, it means we're keeping them balanced. So we're going to look at, now we are going to look at some that are a little bit different, but not just yet. So we're going to look at solving some inequalities, things that have greater than, less than, greater than or equal to, less than or equal to signs in them. And we're going to start with some basic ones, like x plus 14 is greater than 22. So we're still going to look for our variable. The x is the variable. The thing that's happening to it is adding 14. The opposite of adding 14 is to subtract 14. So it sounds just like we're solving an equation. Once we take that 14 back off, I'm back to having just x. I'm going to write my greater than symbol instead of my equal symbol. And instead of keeping it equal, keeping it balanced by taking 14 away from the other side. 22 minus 14 is 8. So that says that x has to be greater than 8 in order to make this inequality true. So let's say, well, I think it might be 9. Could be 9. So if I put 9 in there, 9 plus 14 is 23, and 23 is definitely greater than 22. Now that doesn't mean 9 is the solution. It just says it could be because 9 is greater than 8. So that would work. I could pick something else for x as long as it's greater. So maybe it's 15. 15 plus 14 is 29. And 29 is also greater than 22. So it's anything as long as it's greater than 8. But you can see that the steps to solve it are the same. And now you're going to do a homework assignment on page 242 in your textbook. It is solving a series of equations and then inequalities, numbers 1 through 9, 11, and 12. So you will not be doing numbers 10 or 13. That does include a couple of inequalities. Make sure when you write them that you write the equation, show the step you're going to take on each expression in order to solve it so that I can see that you are treating each expression separately, and that you're keeping them equal or balanced depending on whether you're doing an equation or an inequality.